So welcome to this video. We'll be doing the Edexcel June 2024 A-Level Maths Paper 1. Let's go. So first question, we have g of x equal to 3x cubed minus 20x squared plus k plus 17x plus k. Given that x minus 3 is a factor of g of x, find the value of k. So what does that mean? Well, that means that g of 3 must equal 0. Okay, so then we just plug in 3 for x and we equal that to 0, and that will make us work out k. So we get a 3 times 3 cubed minus a 20 times 3 squared plus k plus 17, and that is x, that is times by 3, and then we have the plus the k, and that's equal to 0. So therefore, we would get a 20, let's do it in one go actually, we'll get a 81 minus 180. We would get a plus 3k plus 51 plus k, and that is equal to 0. So what does that give us? So if we do we get an 81 plus 51, so that would be 132, and then we minus that from 180, so we get a minus 48 here, plus 4k, that is equal to 0. Therefore, we have a 4k is equal to 48, which therefore gives us k as 12. So for this question, we need to find in ascending powers of x the first 4 terms of this binomial expansion. So we've been given the expansion of 1 minus 9x to the power of a half. And for this question, we actually been given this formula in our booklet. Therefore, what we can do is we can just use this formula we've been given in the booklet. So we have the formula right here, 1 plus nx, and then we have the plus n times n minus 1 all over 2 factorial x squared, and then the n minus 1, n minus 2 over 3 factorial x to the power of 3. And we can just use that formula with our values and work out our answer. So we have 1 minus 9x is equal to a half. So that would equal 1 plus, well, n is a half, so it'll be a half, times by x, in this case x is a minus 9x, okay? Then we plus n again, I'll write it as 0.5 this time. And then that is, we're going to minus 1 to that half, so that becomes minus a half, okay? And then that is going to be over 2 factorial, which is just 2. And then we're also going to times by x squared. Now x squared, that x is a minus 9x, so we're going to times by a minus 9x squared. And then for that last value, we'll get a 0.5 again, okay? We'll get the minus 0.5, that's n minus 1. And then we're going to effectively just minus 1 again. So we get a minus 1.5. And then that is over 3 factorial. 3 factorial is just 6. And then we're going to have a, right here, minus 9x to a 3, okay? Okay, so let's simplify this down first. So if we do this, we get a 1 minus a 9x to the 2. If you use your calculator now, feel free. We're going to put all this into our calculator. So what do we do? Well, we just do the 0.5 times the minus 0.5 over 2, and then we times by 81, okay? Because we have that 9x squared, so times by that 2. So that will be a positive 81x squared. If you times all of that together on your calculator, you should get a 81x squared over 8. But once you calculate, you should get this. And then for that last value, you're just doing a calculator, just do the 0.5 times the minus 0.5 times the minus 1.5 over 6, and then times by a minus 9 to the power of 3, okay? If you do that on your calculator, you will get a minus 729x to the cubed over 16, okay? So for part B now, we need to give a reason why that x is equal to minus 2 over 9 should not be used in the expansion. Well, for something to be used in the expansion, it has to follow this rule that the modulus of x has to be less than 1. So in our case, x is a minus 9x, so we have a modulus of a minus 9x, okay? And that's less than 1, which again just makes a 9x, which is less than 1. and then that will be a modulus of x is less than 1 over 9, okay? Now the problem with this is it's saying for minus 2 over 9, but as we can see here, that just wouldn't work, because if x was let's say x was a modulus, let's say x was minus 2 over 9, we'd get a modulus of minus 2 over 9. Okay, and we're trying to say that that is less than 1 over 9, but 2 over 9 is not less than 1 over 9, okay? So that just isn't true, therefore we cannot use that as an expansion. So for question 3, all we need to do is we need to show that alpha lies in the interval 3.6 and 3.7. This question, very easy. We need to prove that by putting in the values 3.6 and 3.7 into x, and they should be opposite signs. So if we do that, so this is A, then first things first, we'll do f of 3.6. F of 3.6, that would be a 3.6 plus tan, and that would be a half times 3.6. And if you work that out, so I'll do it on my calculator now. If I work that out, so also one thing to note as well, we are in radians, okay? So make sure that your calculator is in radians, and then just put that in, so you get a 3.6 plus tan, and then a half of times 3.6, okay? And what do we get? We get I'll just do a lot of values, because why not? We get a minus 0.68626 16746. Okay, I did every single value, why not? And then for the second one, we do f of 3.7, and that would be 3.7 plus tan a half times 3.7. And then if I just do it on my calculator quickly, that will give us a positive 0.211940413. Okay, now as you can see, that is a change of sign, okay, because one is positive, one is negative, hence there is a root in that interval. Okay, you can just write something like that just to clarify that there's a root in that interval. Okay, now for question B, we need to find f dash x, okay? So to find f dash x, okay, if I do B here, well, if I just quickly rewrite f of x here, okay? F of x is x plus tan a half x, okay? Now, for this type of question, we actually, again, can use the formula booklet, because in the formula booklet, they actually tell us they have differentiation in there, and we know that from the formula booklet, it tells us that if we want to differentiate tan x, or if we have, it tells us that if we want to differentiate tan x, then that actually equals k sec squared kx, okay? So by using that, we can just use that to differentiate. So if we have x plus tan x like that, then f dash x, if we just differentiate the x first, well, the x would just go to 1. And with that tan, what we would do is we obviously need to differentiate. We can use chain rule, so we can differentiate what's already in there. So the half x, we take a half out, right? So we get a half. And then it just goes to sec squared, okay? So sec squared, and then it will just be a half x. And that would be f dash x. And now for part C, okay? We need to use 3.7 as a first approximation for alpha, apply the Newton-Raphson method once to obtain a second approximation for alpha. So for this question, again, we're given this in our booklet as well. We're given the Newton-Raphson, so if you don't remember it, then it is completely fine. And what the Newton-Raphson is this over here. It is that if we have x, n plus 1, that is equal to xn minus f of xn over f dash xn, okay? So that is what the Newton-Raphson is. So they've told us that we need to use the approximation. They've told us here that we need to use the approximation of 3.7, okay? So therefore, what does that mean? That means that if we write x, let me do a different way. Let's say that x0 is 3.7, okay? That means that x1 would be x0 minus f of x0 divided by f dash x0, okay? And in our case, that would just be a x1 is equal to a 3.7 minus f of 3.7, which we know from part A, and then we just need to use f dash x and put 3.7 in, okay? Like that. So if you were to do that on your calculator, I don't think I need to explain to you how to do this into your calculator, but effectively all you really probably want to work out now is maybe just f dash 3.7, okay? So if you want to work out f dash 3.7, then what I'll just do is, first things first, you may want to rearrange this one here. Rearrange this because we have 1 plus a half sec squared, a half x, but you obviously can't really do sec squared on your calculator. We need to change that into cos. So just quickly, you can change that to a 1 plus. And what would that be? Well, that would just be a 1 over a 2 cos squared a half x, okay? We've just changed that sec squared into a 1 over cosec squared. And now you can put that into your calculator, okay? If you were to work that out on your calculator, if you put 3.7 into the f dash x, you would get a 7.5832798. So now we have all of our values, okay? So now let's just work this one out. So what do we do now? Well, we would know that x1 is equal to a 3.7 minus f3.7, which we worked out in the first question. So that was the, let's say, 0.212. And then that'll be over the 7.583. Make sure when you do this, though, you do it to the most accuracy as possible, okay? So you put that into your calculator, and bear in mind, put all your values in to make it as accurate as possible. To 3 decimal places, you would get a 3.672. Okay, so for this question, we need to, given that y is equal to x squared, we need to use differentiation from first principle to show that dy over dx is equal to 2x. So this formula has been given to us in the booklet, so I've written it right here, but it's in the booklet as well. So how does this work? Well, what this means is that as the limit of h tends to 0, f of x plus h, in this case, if y is equal to x squared, that means that x plus h, that means that x is effectively going to be x plus h squared, okay? F of x would just be the x squared, and then that is just dividing by h. So therefore, as the limit of h tends to 0, now if we expand the brackets out, we get x squared. Okay, we'll also get an x times a h, which is an xh, and then another x times h, so another xh, which gives us a 2xh plus h times h, which is h squared, and we get the minus x squared, and that is over h. So therefore, again, we have the limit as h tends to 0. If we simplify this down, the x squared cancels out. We're left with 2xh plus h squared over h. Now, as you can see, everything has h in it, so we can cancel out the h's. So we're left with, as the limit of h tends to 0, we are left with just 2x plus h. And then if the limit of h tends to 0, then what does that mean? Well, we can effectively just get rid of our h. And therefore, we are left with just 2x. Okay, so for this question, we have this f of x is equal to 2x minus 3 over x squared plus 4, and we have f dash x is equal to ax squared plus bx plus c over x squared plus 4 all squared, okay? And then we need to show that f of x equals that f dash x. So if we look at this, we need to differentiate, and it's in that fraction form, so we can just use the quotient rule, okay? So if we use the quotient rule, then what do we know? Well, we know that we know that g of x is equal to a 2x minus 3, and we know that h of x is equal to a x squared plus 4. You can also use u's and v's. I just use g of x and h of x. And if we differentiate this, what do we get? We get g dash x, that would just be a 2. H dash x, that would just be a 2x. And what is the quotient rule? The quotient rule is this, okay? The quotient rule is that if we want to look out f dash x, therefore it would be a g dash x h of x minus a g of x h dash x, and that is all over hx squared, okay? So knowing that, then we just put in our values. So for that first one, okay, we have g dash x times h of x. That'll be a 2 times the x squared plus 4. So it'll be 2 times x squared plus 4 minus g of x times h of x. That is minus the 2x minus 3. And that is being times by 2x. And therefore, that would be a h of x, so we know that's x squared plus 4 squared, okay? And now all we need to do is just simplify this down. If we simplify this down, we get a 2x squared plus 8. We get a minus 2x times a 2x, so that is a minus 4x, and we get just the minus times the minus, so that's a positive 3. Okay, positive 3 times the 2x, that'll give us a positive 6x. And also I forgot to mention that this is a minus 2x times a 2x, so I forgot, but remember to include your squared there. It's important. And then that is all over x squared plus 4 squared. And then just simplify this down, and that will give us what we want in that form. And if you do that, you would get a minus 2x squared plus a 6x plus an 8, and that is over x squared plus 4 squared. That is in the form which they want, and that it will be the answer. So for part B, we need to find the values of x for which f is decreasing. So if something is decreasing, then that means that f dash x is less than 0. So we need to put our f dash x and make that less than 0. So in that case, then if we were to solve this, so we need to find the values of x. If we're to solve it, well, that must mean that minus 2x squared plus 6x plus 8 has to be less than 0, okay? And now we just have an inequality, and we need to solve this for x. So therefore, if we solve this, what I'm going to do is let's just, everything can be divided by 2 first, so let's just do that. So what do we get? We get this here. So we get the minus x squared plus 3x plus 4. That's less than 0. And now we're going to times everything by minus 1, or you can think of it as the other way, dividing by minus 1. But whenever you do this, obviously your inequality flips, okay? So whenever you divide by negative, your inequality is going to flip. So therefore, if I do that, we get x squared minus a 3x minus a 4. And now this is going to be greater than 0. And now this is a normal quadratic we can solve. So yes, two numbers which can sum to make a minus 3, multiply to make a minus 4. 4 and 1, we need to figure out which one's positive, which one's negative. So in this case, we will get a minus 4 here, and we will get an x plus 1 here, and that is greater than 0. Therefore, our x values, we get a x equal to 4, and we get x equal to minus 1. If we draw a little graph just to signify how this is going to look on the graph, then effectively what's going to happen here? Well, we've got this quadratic of x squared minus 3, so we know it's going to be a positive quadratic. We have a positive x squared we're using. We know it goes through the points of minus 1 and 4, so that would look something like this, okay? Not the most accurate, but it does what it needs to do. We have minus 1 here, we have 4 here, and we want it when it's greater than 0. So greater than 0 would be like all of these values above the x-axis here. Therefore, we know that our answer is going to be when x is less than minus 1, and then also we have when x is greater than 4. And also, you don't need to do it this way too. You could also have left it and left it as a minus x squared plus 3x plus 4, and you could have worked out that way as well. You get the exact same answers. Your quadratic would be in that N shape, the opposite way, and you'd still get the exact same values. Doesn't matter which way you do it, you get the same answer. So with this question, we have y is equal to 3, the modulus of x minus 2 plus 5. First things first, we need to work out the coordinates of P, okay? So this question, as you can see from the graph, it's obviously a mod graph, okay? So it can never go below the x-axis, okay? It's modulus. But as you can see, this is like a transformation because with it's been multiplied by a scale factor of 3 in the y-axis. It's also been shifted to the right 2 units, and it's been shifted up by 5 units, okay? So with all those things, though, looking at this graph, well, if we think about it, all like the transformation where it gets shifted by a scale factor of 3 and then shifted up by 5 units, it doesn't actually affect your x value, okay? So our x value really doesn't change that much. The x value, if we think about it, like if we just had y is equal to the modulus of x minus 2, then it's not really changing much from that, okay? It's just been like that x value will still stay pretty much the same if it was just y equals x minus 2. So we can just work out what x minus 2 is. And if we work that out, well, if we think about that, then with this graph here, if it was just y of modulus x minus 2, then we can just work out where it's going to cut the x-axis, and that will be the same x coordinate, okay? So if we do that, we would get a 0 is equal to a modulus of x minus 2. In this case, we can make that just the positive, because we'll look at it as just positive x minus 2, doesn't really matter which way, and then we get x is equal to 2. So what does that mean? That means our x coordinate is 2, okay? That means that like this point here, this here, that is a 2. Okay, it's not going to change, because if you think about it, if we multiply by a scale factor of 3 and then we shift up by 5 units, that is not affecting our x coordinate whatsoever, okay? So it would still be at 2, okay? So if we just had the modulus of x minus 2, if we do all the transformations, the x coordinate isn't changing. So therefore, we know that the x coordinate is still 2. And once we know the x coordinate is 2, all we need to do is use the formula. So they tell us what y is. We know that y is a 3, then the modulus of x minus 2 plus 5. Now we can just simply just sub in our values. So we have y is equal to 3, the modulus of 2 minus 2 plus 5. That gives y as 5. So our coordinates for P is just 2, 5. Okay, so for part B now, we need to solve this equation of 16 minus 4x is equal to 3x minus 2. That's all modded, and that's plus 5. We need to solve that equation. Okay, so what I've done here is, first things first, what we can do is we need to figure out 2 things. We have here that I've written that when we have the mod of x minus 2, that is equal to x minus 2 only if x is greater than or equal to 2, and it will be a minus, all in brackets, x minus 2 if x is less than 2. That is important. When we're dealing with modulus equations, we could get extraneous solutions. So once we get our solutions, we need to verify that they're actual solutions and they're not extraneous solutions, okay? So we can solve, so obviously with mod, we solve it 2 ways. We first consider that it's going to be just like the normal positive way, and then we consider it's going to be the negative way. So if we do that, so if we consider the positive way first, we will have a 16 minus 4x is equal to a 3, just normal x minus 2 plus 5. So it's a 16 minus a 4x is equal to, if we do this side all in one go, we get a 3x minus a 6, and then plus that 5, it will give us a 3x minus a 1, okay? And then if we solve this now, we will bring that 1 to the side, so we get a 17 over here, and then we get a 7x over here. So we would get x is equal to a 17 over 7. So let's just check this first. So 17 over 7, looking at that, that is going to be 2 point something, okay? It's going to be 2 point whatever. But the fact of the matter is, it is above 2, okay? Because we consider that x would just be the normal positive. We consider that we used x minus 2. And this only is valid if our x value is greater than 2. Well, our x value is greater than 2 because 17 over 7 is greater than 2. Therefore, this is all good. We accept it. Okay, now let's consider it the other way, okay? Let's do the same thing, but now let's consider the negative direction. So we would have a 16 minus 4x, and that is equal to a 3, but now that'll be times by the minus x minus 2, okay? We'll just change it now. Now we're going to be times by that minus. So if we do that, therefore that is just going to be like a minus 3x minus 2 plus 5, which is a 16 minus 4x. We'll get a minus 3x plus a 6 plus 5. That's a 16 minus a 4x is equal to minus 3x plus 11. And therefore, what does that give us? That gives us, if we, again, we'll bring that 11 to the side, so we get a 5 here, and we get an x here. So that gives us x is equal to 5. So we get x is equal to 5 here, okay? But if we look up here, when we are considering the negative way, okay, in this case, x has to be less than 2. But we have x is equal to 5. So we have that 5 is supposed to be less than 2, but 5 is not less than 2. Therefore, this is an extraneous solution, and we don't include that. Therefore, our answer is just going to be 17 over 7. Now, for part C, I will do this just on the graph to make it easier. But effectively, for part C, okay, we have the line L. If I show you, we have the line L. It has the equation y equals kx plus 4, where k is a constant, okay, and it says that given that L intersects the graph at 2 distinct points, we define the range of values of k. So if I use this graph here, then what effectively is it saying? It's saying that we have something which is y equals kx plus 4. Also, let me just note that we know that this point is 2, 5 as we worked out in part A. So what does that tell us? Well, if we have something which is y equals kx plus 4, that must mean that it's going to be somewhere like, let's say, here, right? This could be where this line is, because we know it has a y-intercept of 4. We know that p is 2, 5, so we know it's going to be just below p. So by looking at that, we know that it intersects 2 points. So let's just draw a line, a straight line, okay? Let's just draw a straight line like this, okay? As we can see, this intersects 2 distinct points, okay? Now, one thing to note is, as you can see, that in order to intersect 2 distinct points from where the intersect is, the graph has to be a positive. So already we know that k has to be positive values. It cannot be a negative, because think about it this way: if you had like a negative value, like a negative gradient would be something like this, or it would be like, you know, this. But the point of the matter is, if you have a negative gradient, you can only intersect one like at one point. So just by that, we know that it has to be a positive gradient, okay? Now, one thing to note is, obviously I've drawn my y-intercept there, but we don't know where this, but obviously it's hard to scale it. But the whole idea of this is we need to figure out pretty much when it will always have 2 distinct points. So if we think about it, right, again, there are 2 points we want to consider. We want to consider when the line is going to be the same gradient as this line here. So like effectively like that line here, like when it's going to be, I guess, like you can think of it as more parallel to that line, okay? It's only going to really intersect at one point, okay? And then if it's parallel to that line, therefore it won't intersect at 2 distinct points. That's only when it's going to be parallel to that line, okay? So again, what is that line? What gradient is that line? Well, we already worked out that a long time ago, because we know that that line, we know what the graph is. We know the graph is y equals 3 of mod x minus 2 plus 5. We know that that line is the positive variation, so that'll just be a 3x minus 2 plus 5. So we know that is just the 3x minus 1. Okay, we already worked that out anyway. But effectively, what do we know? We know that the gradient of that is the 3. Okay, we know the gradient is just the 3. So we know that when we have our line, and when it's going to be parallel to that line, we know that, okay, it's going to have 1 point. So therefore, our answer, therefore, that once the line keeps getting steeper, once it gets past that gradient of 3, it won't have any more solutions. Okay, it will just have one solution. So therefore, we already know that in that direction, 3 is the highest our gradient can be. So we know 3 is our highest the gradient can be. Okay, cool. Another thing we want to consider is when we get below this 2, 5, okay, again, it's not going to intersect at 2 lines anymore, okay? So it'll just intersect at that 1 point, and that will be it. So again, we need to figure out what would the gradient of this line be at that point. Well, if we know that we're dealing with y equals kx plus 4, then we can just work out what the gradient would be at that point, because we already have our x and y values. So that would just be a 5 is equal to a k times 2. We just put in the 2 and 5, and that will give us our gradient for k. And by doing that, we get a 5 plus 2k plus 4. So we get a 2k is equal to 1, a k is equal to a half. Yeah, so effectively, this is effectively what we're doing here. It's like we've got this kx plus 4, and we're trying to figure out when it will hit 2 solutions. So keep hitting 2 solutions, still hitting 2 solutions, still hitting 2 solutions. Even here, it will still hit 2 solutions. Obviously, it doesn't look like it will on a graph, but it will still hit 2 solutions, because eventually it will just cross at a further point up on the graph. We just can't see it. So still hit 2 solutions here, but then when it gets parallel to that line, that's when it won't hit 2 solutions anymore. So we know that that's why when it's parallel to that line, it won't hit 2 solutions anymore. So if we can work, so this would be at when the gradient is 3. And then, as we know, it's going to hit 2 lines, 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 and then it'll get to here, and it'll just hit a 1 point. And that is at the 2, 5, which we worked out as gradient a half. Therefore, we know that our answer would just be when k is between a half and 3. So for this question, we have this cylinder tank here, okay? Initially, the tank is full of water. The water starts to leak. We've been given this differential equation, dh over dt is equal to minus 0.12 e to the minus 0.2 t. And we need to show that h is equal to ae minus 0.2 t plus b. Okay, so it's a differential equation we need to pretty much integrate, okay? So effectively, we have dh over dt, and we need to prove that h equals something in this form here of ae minus 0.2 t to the b. So first thing first, let's integrate. Well, integrating this is fairly simple. We just need to bring that dt to the other side and integrate both sides. Effectively, if we do that, we'll just be left with h is equal to a minus 0.12 e to the minus 0.2 t, and then we integrate that with respect to t. So again, that h, we can take that 0.12 out, and then just integrate the e minus 0.2 t dt. And if we integrate this, well, we're left with h minus 0.12. And then if we work out what e to the minus 0.2 is, well, effectively, it's like we're taking out, if we like use a reverse chain rule, do it in my head, it's like we're taking out like 1 over a minus 0.2. So 1 over a minus 0.2 is 5. Okay, or minus 5. E to the 0.2 t. Okay, and then we just need to add our constant. So if we work this out, we get a 0.6 e to the minus 0.2 t plus c. Okay, and now we was told in the question that initially the tank is full of water initially. So what does that mean? Well, if we look at the diagram here, if initially the tank is full of water, well, the maximum height of the tank is 1.5. So the height would be 1.5. So if the height is 1.5, it's initially, which means that t would be 0. Therefore, we know that it is when t is equal to 0, when h is equal to 1.5. That will enable us to find out our constant. So now we put in our values, work out our constants. So that would be a 1.5 is equal to a 0.6 e minus 0.2 times by 0 plus c. That will give us a 1.5, and that is equal to a 0.6 Okay, and with that 0.6, we get an e to the 0, which is just 1, so that stays at 0.6 plus c. Therefore, our c value is just going to be 0.9. So therefore, if we rewrite this now, that means that h is equal to a 0.6 e minus 0.2 t plus a 0.9. And we've given it in the form they want. They want it in the form of ae to the minus 0.2 t plus b. We've given it in that form where a would be the 0.6 and b would be the 0.9. So that second bit now, we have to find the time taken for the depth of the water to decrease to 1.2 meters. Okay, so for this question, we define it to the nearest minute. Okay, so to do that question, let's do it over here. For B, okay, we are told that we want to find it when the height is at 1.2 meters. So all we need to do is using our h now, our h is equal to 0.6 e to the minus 0.2 t plus 0.9, just make h equal to 1.2, like this, and then that would equal the e minus 0.2 t plus 0.9, and then just work out your t value. So if we do that, well, we'll bring that 0.9 to the side, so we get a 0.3 is equal to a 0.6 e to the 0.2 t, divided by 0.6, which will give us a half, because 0.3 divided by 0.6 is a half, so we get a half is equal to e minus 0.2 t. Now we can take luns, so we do a lun, we get a lun, a half is equal to a lun e minus 0.2 t. Now we can split up this lun into lun 1 minus lun 2, and then the luns times e would cancel out, so we're left with 0.2 t. And another thing to note is lun 1 is equal to 0, therefore we're left with a lun 2, a minus lun 2 is equal to a minus 0.2 t. And then from this point on, all we need to do is just do a minus lun 2 divided by a minus 0.2. And if you do that into your calculator, you will get something like a 3.46, let's say 4657 hours. Okay, now we want it in to the nearest minute. We want in hours and minutes to the nearest minute. Now t is in hours, so first thing first, I would say just times that by 60. So if you times this by 60, you will get something like, times that by 60, you'll get like 207.09. So now this is in minutes, and this is in minutes, and we want this now to the nearest minute. Okay, so that would just be 208 minutes, but we want to give an answer in hours and minutes. Therefore, what's 208 minutes in hours and minutes? That is simply just 3 hours and 28 minutes. So in the long term, we have that the water level of the tank falls to the same height as the hole. We define, according to the model, the height of the hole from the bottom of the tank. So what I'm basically saying is, they're saying that it will eventually fall to this point here. Okay, the water will just fall to that hole. We define what the height is at that hole. Now, to work that out, effectively what we're saying is, what are the constraints of this? What are the limits of h? Okay, so we're pretty much finding out, like with t, like what is the limits of h? Well, what do we know about this type of question? Okay, well, we know that in this case, we know that e to the minus 0.2 t, right? That is always going to be a positive value. It's always going to be a positive value. Okay, it will always be greater than 0. And if we were to times both sides by 0.6, we know that 0.6 e to the minus 0.2 t, that will also always be greater than 0, okay? Which means that if we do 0.6 e to the minus 0.2 t plus 0.9, we add 0.9 to both sides, that must mean that for this model we can never get a value less than 0.9. It will always be greater than 0.9, okay? It can never be less than 0.9. because due to the values we're using, due to the fact that E always has to be positive, 0.9 has to be the minimum. Like, that has to be the minimum. Therefore, we know that H is equal to 0.9. We know that the smallest value for H we can get with this model is 0.9 meters. Therefore, the water level in the tank, it falls the same height as the hole. According to the model, that has to be 0.9 meters, okay? Therefore, we know that the height from the hole from the bottom tank is just 0.9 meters, okay? Using the model, it is the smallest value. It is the lowest value we can possibly get, okay? So it has to be at 0.9 meters. Okay, so for question 8, we have f of x here, we have g of x, and we need to find f of g of 2. So to do that, let's just work out g of 2 first. So g of 2, that would just be 5 over 2 times 2 minus 9, which is a 5 over minus 5, which is a minus 1. If we know that's a minus 1, we know that f of g of 2 is the same as f of minus 1, and f of minus 1 would just be a 4 minus a 3 times a minus 1 squared, which is a 4 minus a 3, which therefore is just a 1. For part B, we need to find g to the minus 1, so the inverse of g. So to find the inverse of g, okay, then what we can do is we can effectively just make the x and y values, flip them. So we can do x is equal to a 5 over 2y minus 9, and then we could just now rearrange for y. Okay, so if we do this, then we will get a, if we times everything by 2y minus 9, we will get a 2xy minus a 9x is equal to 5. And then we would get a 2xy is equal to a 5 plus a 9x. And then we just need to divide by 2x. So we get a 5 plus 9x, and that is divided by 2x, okay? And that would be our g to the minus 1. Also, don't forget to include your domains as well. So as you can see, if we have 5 plus 9x over 2x, then the domain will be any real value, because x can be any real value except for 1, though. That 1 value is 0. So we just need to include our domain too. So x is any real number, but x cannot be 0. Okay? And for part C, we need to find g of f of x given my answer as a simplified fraction, and then we need to deduce the range of g of f of x, okay? So for this question, if we do g of f of x, okay, then what would that look like? Well, it would be 5 over, so originally it was 2x minus 9, but we're putting that f inside of it, so it would be 2 times that 4 minus 3x squared, and then that minus the 9, which will give us a 5 over a 8 minus 6x squared minus 9, which simplifies down to a 5 minus 1 minus 6x squared, and then we can just bring that minus to the top. So just to make it look a bit more pretty, we can make it a minus 5 over a 1 plus 6x squared. Okay, so that is the first bit. That is just g of f of x. Now we need to deduce the range from this, okay? So to work out the range, how could we do that? Well, if we think about it, okay, what would the range be? So what would if we had the x and y values, what is the maximum and minimum y values we can have? Well, if we think about this, we know that with 6x squared, okay, this will always be greater than or equal to 0, okay? Because it's a squared number, it will never be a negative value, okay? The lowest it can be is 0. Therefore, if we have 1 plus 6x squared, this will always be greater than or equal to 1, okay? So we know that. Now, the way we can think about this is for any value of x, because x can be any real number in this case, right? If we just think about it for a second, right? Let's just say that x was, 1 plus 6x, it will always be greater than or equal to 1. So effectively, what does that kind of look like? Well, if we think about it, that means that for that denominator, right, we can get 1. 1 is the lowest value we can get, okay? But it will keep going up. It will keep going up to infinite, right? So therefore, we can have like a minus 5 over 2 as well. The denominator can be 2, okay? It can also keep going up to 3 and 4 and 10 and 20 and 25 is just 5. And it will just keep going up like this, okay? It will just keep going up like this, okay? And effectively, what's going to happen is, if you think about it, let's say we have 100 here, and then let's say we then get 5 over 200, 5 over 1,000. As you can see, our denominator is going up to infinite. So it's going to keep getting, in theory, it's going to keep getting smaller and smaller and smaller. But that value it will keep getting is that it will never be a positive number. It will never even get to 0. But it will keep getting smaller and smaller and smaller, and it will tend to 0. It will go as close to possible to 0. Therefore, we know that for our range of f, we know that the biggest value, or no, the smallest value we can get is minus 5. That's the smallest value we can get, okay? And then for the upper range, well, as the x values are keep going up, the x values are real numbers, right? It can be any real number, so the x values will keep going up to infinite. You know, as the x values increase, we'll get close and close to 0, but we'll never actually reach 0. Therefore, it's just going to be less than 0. So the range is just between when it's equal to minus 5 and when it's less than 0. So for part D, we need to find the range of values of k for which the equation f of x equal to h of x has no real solutions. So if something has no real solutions, what does that mean? It means the discriminant b squared minus 4ac has to be less than 0. First things first, we need to work out what our equation would be. We know that f of x is equal to h of x, so we can write an equation for that. We know f of x is 4 minus 3x squared. We know h of x is 2x squared minus 6x plus k. So if we put that all together, we would get a 5x squared. We just still have that minus 6x, and then we would get a k minus 4, okay? That is equal to 0. So if I rewrite that on this side, it'll be a 5x squared minus 6x plus the k minus 4. I put it in brackets so we know that's our constants values. And that, in this case, what would that be? That would be equal to 0. Okay, now we know that for the discriminant b squared minus 4ac is less than 0. What would our values be? Okay, so for this question here, okay, our values would be, well, we would have a as 5, b as minus 6, and c as k minus 4. So if we do b squared minus 4ac on that, that would be a minus 6 squared minus 4 times a, which is a 5, times c, which is the k minus 4. And we know that has to be less than 0. So we get a 36 is a minus 20 k minus 4 is less than 0. 36 minus a 20k plus 80 is less than 0. We would get a 36 plus 80 is a 116, that is less than 20k. And then if we work this out, if we did 116 divided by 20, we would get a 5.8, which is less than k. Therefore, if we rewrite this, that would be a k is greater than 5.8. So we know that for the range of values of k has to be greater than 5.8. When k is greater than 5.8, we have no solutions. Okay, so for this question, we need to use algebra, prove that k is equal to 5 over 2. So for this question here, what we can do is it's a geometric sequence. So we know that our r, like we know that the common multiplying value, okay, we know that that's always going to be the same. So first things first, what can we do? Well, we can actually just divide. So what I'm going to do first is I'm going to work out my r value here. So we know that we're going to have the same r value. These are going to be the same r values if we times them, okay? So what I'm going to do is I'm going to divide. I'm going to do 9 and then 7 minus 2k. I'm going to divide that by the 4k plus 5. And if we work this out, we would get I'm going to rewrite this as a 3 squared, because we know 3 squared is 9, 7 minus 2k over 4k minus 5. And then from that, what we can do is they're both being divided by 3, so we can actually just do 3, and then that would be if I let me just simplify it down now, expand it out, so that would be a 14 minus a 4k, and we know that will be minus the 4k minus 5, okay? And that would equal a 3. 14, we get a 14 minus a minus 5, so that would be a 19 here. And a minus 4k minus a 4k will give us a minus 8k. Okay, so we know that for r, we've got r as, our multiplying value is 3, 19 minus 8k. Now we're going to do the same thing for the second and third term, because the second and third term, they're also being multiplied by the same thing. If we do that, therefore, what do we get? We get a 3. Let me see what the value was. It was a 2k and then minus 1. And if we divide that by the 9, 7 minus 2k, again, we will do 3. And then we expand that out. So we get a 2k minus 2. And that will be divided by, well, we know that we did this in the last question, so we know that that bit would equal a 3, 14 minus 4k. And then if we work this out, we would get a 3, 2k minus 2, and that would be minus the 14 minus 4k, and that would give us a 3. And then we get a 2k minus a minus 4k, so that's 2k plus 4k, so that would be a 6k. And then we get a minus 2 minus a 14, which gives us a minus 16, okay? So now we're at minus 16. And now we're at this stage. Well, we know that this is also going to be r. We know that r is also going to be a 3, 6k minus 16, okay? But we know r is the same. So we have r is equal to 3, 19 minus 8k. R is equal to 3 to the power of 6k minus 16. Make them equal to each other, okay? So if we make them equal to each other, we get 3, 19 minus 8k is equal to a 3, 6k minus 16, which means that 19 minus 8k is equal to 6k minus 16. And if you rearrange for this, we would get a 35 over a 14k. So k is equal to 35 over 14, which if you simplify this down, you end up with 5 over 2. Therefore, we're proving that k is equal to 5 over 2. Okay, so for part B, we need to find the sum to infinity of this geometric sequence. So now obviously we know that k is 5 over 2. We can just plug in 5 over 2 for k to work out our actual values. Now if you do that, you will get 243 as the first term, then you get 81, then you would get 27, okay? As you can see, we're just dividing by 3 each time. If we're dividing by 3 each time, effectively that's the same as saying we're timesing by 1 over 3, okay? And as you can see, this is a converging sequence, okay? Our values are getting smaller and smaller. They are going towards 0. So we know that obviously when we have a converging sequence like this, okay, we know that the sum for a converging sequence, it is just going to be, to sum to infinity, it will just be a, where a is your first term, over 1 minus r. Now, in this case, what would that be? That would just be 243 over 1 minus r, so 1 minus a third. And if you used to work that out, you would get a 729 over 2, which is a 364.5. And you kind of verify this as well, because if you think about it, well, if we were just to add, like for example, we know that we get a 243, we get an 81, 27, the next value would be a 9, and then a 3, and then a 1, and then we keep going down. If you used to add all these numbers together, well, looking at this, we would get a 324, and then we'd get a 351. We add the 9, we get a 360. We add the 3, we get a 363. We add the 1, we get a 364. As you can see, that then with that we get a 364.33, and then as you can see, it's gonna get as close to possible to the 364.5, but it will never touch. So you can always verify your answer just by thinking about it, like what would it really go to? But yeah, answer is 364.5. Okay, first question, we have this graph here, and this we need to verify that the x coordinate of A is 4. So very easy to verify if the x coordinate of A is 4. As we can see, where A is, it's on the x-axis. So that must be 4, 0, which means that if x is equal to 4, our y value must equal 0. So all we need to do is plug in our value of 4, and we should get y is 0. So if I do that here, we get y is equal to 8 times 4 minus 4 to the power of 5 over 2. Okay, which gives me a 32. And then that'll be a square root. So we get a minus 2, and then, yep, okay. Oh, also just bear in mind that this is not a minus 4 to the power. This is a minus times 4 to the power of 5 over 2. And then that gives us a minus 32, which gives us a 0, which makes sense. We should get a 0 because it's on the x-axis. Hence, we've proven it. It's a 1 marker. Don't need to explain anything. Just do that. You're good. So for part B now, we need to use calculus to show that there's an equation of line L1 is 12x plus y is equal to 48. Okay, so line L1, as you can see, is just a tangent to this curve here. So how can we work that out? Well, what do we know? Well, first things first, let's think about the equation of a straight line is just y take away y1 is equal to m, x take away x1. Okay, what do we know so far? Well, we know that if we look to the graph, we know that that L1, it hits at A, okay? And we know that A is 4, 0. So we know that A is 4, 0, okay? We just need to work out the M value. Because if we work out the M value, then we can use the equation of a straight line. So right now we have that X is 4 and we have that Y is 0, but we just don't know what that M value is. So we need to work out the M value. Now, so how can we work out that M value? Well, if we look at the graph here, we know that that curve, it also hits at A, okay? And so we know that if we can work out the gradient of that curve at x equal to 4, we'll know the gradient at that point. And that gradient will be the same as L1. So effectively, if we know that we have y is equal to 8x minus x 5 over 2. If we look at the gradient at 4, it'll be the same gradient when it intersects, okay? And therefore, we can just use that value to then work it out, okay? So if we do this, first things first, we're going to differentiate. So we'll do dy over dx is equal to 8, I mean it's bigger, 8, and then for that one, it would be a minus 5 over 2 x, and then if we minus 1, we get a 3 over 2. And then just put in our value of 4, okay? So we get 8 minus 5 over 2, 4 to the power of 3 over 2. If you work that out, you get an 8 minus a 5 over 2 times by a 8, which is 8. And therefore, what would that be? That would be a 20 minus 20, which gives us a minus 12, okay? So we know that the gradient is minus 12. If we know the gradient is minus 12, we have our x, y, and we have our gradient now is minus 12. We can just plug that in. So we have y minus 0 is equal to a minus 12, x minus a 4, and that will give us a y is equal to a minus 12x plus 48. And if you rearrange that, we will get it in the form which the question desires, and that will give us our 12x plus y is equal to 48. So for the next question now, we need to find the exact area of R. Now, the thing about R is when you look at it, right, instinctively, you're going to just think that you just need to integrate with your limits of 0 and 4 and you get the answer, right? But just remember that when we're integrating, right, integrating is always going to give us the area under the curve. So there's actually two parts we need to do here. The first bit is, if you see, the area under the curve is this. This is the area under the curve. That is the area under the curve, okay? So if we do integrate, so if I just do it a bit here quickly, the integration of before 0, right, of the 8x minus x to the 502, right? That is what we are talking about, okay? This is that. It's that area, okay? It's not, remember, it's always below. Some of you may just do that, but no, that just gives you area below. But we want R. So how do we work out R? Well, to work out R, we will need to integrate that. But to work out R, as you can see, there's a whole triangle forming here. Like, there's a whole triangle here. Okay? Like it's this whole triangle, okay? This is what we need to work out as well. If we work out the area of this triangle here, we can then take that away from the area under the curve, and that'll give us the area of the shaded region R. So, first things first, what are we going to do? How do we work out that area, okay? Well, if we go to the question, they do tell us some information which we need to know. They tell us that L2 has equation of y equals 8x. Okay, so if we look at L2, we know that L2, it has the equation y equals 8x. And that intersects with L1 at the top of the triangle, right? So if we work out what that point is, whatever that y value is, we know that would be the vertical distance. We already know that the horizontal distance of that is going to be 4, okay? We already know that this bit here, okay, we already know that this is 4. And we used to work out the vertical distance, okay? Which if we work out what this value is, it will give us that y coordinate, which will be the vertical value, and then we can use that to work out the area. So let's work out when it intersects, okay? So let's look at when L2 and L1 intersect. So if we have L1 and L2, okay, so that was part B, this is now part C. If we work this out, then what do we know? Well, we know that L1, that was the 12x plus y is equal to 48. We know that L2 is equal to 8x, okay? So we know they intersect, okay? Their y values intersect. So if we have this, then what do we do? Well, that means that 12x plus y, with y is equal to 8x, that'll be 8x is equal to 48. Therefore, 20x is equal to 48. Therefore, x is equal to 48 over 20, which simplified down, we get a 24 over 10, which gives us a 12 over 5. Okay, so we know that our x value is 12 over 5, okay, or 2.4. Now, we can use that to work out our y value now. Now, our y value would just be that 2.4 or 12 over 5. It will just be times by 8, okay? So if we work that out, what do we get? We get a 8 times a 2.4. If you work that out, 8 times 2.4, you get a 96 over 5, which is 19.2. So what do we know? Well, if we know that's 19.2, we know that this value here, we know this coordinate here is a 2.4, 19.2, which means that this is a 19.2, has a vertical distance of 19.2. So we know that if I just do it here quickly, we know that this is 19.2, and we know that this here is a 4. We can work out the area of that triangle now. So if we work out the area of that triangle, it would just be, so right here, area of a triangle is just going to be a half times the 4 times the 19.2. Okay? And if you were to do that on your calculator, you would get a 192 over 5. Okay, so now we know the area of that triangle is 192 over 5. Now, work out the area under the curve. That will give us that region I've shaded in blue, and then we just take them away from each other. So, to do that, now we can just integrate. So now we will integrate. So we'll do integration of 4, 0 of 8x minus x 5 over 2. Okay, we'll integrate this. And if you integrate that, well, what do you get? You get a 8x that integrates to a 4x squared, okay? And for that other value, we're going to plus 1, so we get a 7 over 2, divide by 7 over 2. So what does that give us? That gives us a minus 2 over 7x 7 over 2. And then we would have our limits of 4 and 0. Okay? And now if we work this out, what do we get? We would get a 4 squared minus 2 over 7 times 4 to the power of 7 over 2. And then we would just get a minus 0 on this side because obviously all of them would just equal 0. So therefore we're left with this. If we simplify this down, we get a 64 minus a 2 over 7. That 4 we're gonna square root it. So that's 2 to the power of 7 is a 128. And then if we work this out, we get a 64, and that would be minus a 256 over 7. Okay. Whew. And then we're at this stage. If you work this out, if you can make that 64 over make it with a denominator of 7, so you get a 448 over 7 minus 256 over 7, which leaves me with 192 over 7. So what do we know? We know that the area under the curve. We know that this value here is 192 over 7. We know the whole area of the triangle we know is 192 over 5. Okay, it's these two values here now. Now we just need to take them away from each other. Obviously, we take the area of the triangle away, so that would be 192 over 5 minus 192 over 7. And if you was to work that out on your calculator, you would get 384 over 35. Okay, so for this question, we have this figure 4 here. We have this shape, and it's a semicircle with center O and diameter 10 centimeters. We're told that OB is the arc of a circle with center A and radius 5 centimeters. We're told about the region R, and we find the exact area of R. Okay? So this question, we find the exact area of R. Well, first things first, we have a semicircle here. So we know that with a semicircle, it's just going to be, the area will just be a half pi r squared. Okay, that's the area of a semicircle. So we know that. So that is, I guess, easy. And we can actually work that out now, to be honest. We have everything we need to work out the area of the semicircle, because we know what the radius is. The radius is 5, so we can actually just work that out straight away. So that would be a half times pi times 5 squared. So that will give me a 25 pi over 2. Okay, so we know that the area of the semicircle is 25 pi over 2. Now what we need to do is work out this area here. Okay, we have this area here we need to work out. How do we work this out? Well, the first things first is let's just write down some values. So we know this is 5 centimeters, right? This is the radius. This is 5 centimeters. Okay. Well, what else do we know? Well, they tell us that we have OB, so make small. With OB, that is the arc of a circle with center A and radius 5. So this tells us that OB is the arc of a circle with a center A. That means that effectively it's like they're telling us that this is like another circle here. Obviously, this is a bad drawing. Effectively, that's what they're telling us here. They're telling us that this is another circle. That's the arc of a circle like this with a center A. Imagine A is in the center. I know my drawing is awful, but imagine A is in the center of A. Therefore, what does that actually mean? That means that that means that if you draw a straight line to AB, that must also equal 5, okay? Because they tell us in the question that it has a radius 5. So if we have a center of A and the arc is OB, that also must mean that the center, well, the segment, you can say, from A to B, that is just 5, okay? So we know that's 5, okay. Then also, because we have this circle and we have the centers and everything, we also know that due to this being the arc and then we're the center of A, we also know that OB, this must also be 5 centimeters as well. And as you can see, we have all these sides equaling 5 centimeters. If everything equals 5 centimeters, then this must mean it's an equilateral triangle, okay? Which means that if it's an equilateral triangle, all the angles must be 60 degrees, or in this case, because we're dealing with arc lengths, we're dealing with radians, we know that every angle here must be pi over 3, okay? Must be pi over 3. Now, if we know that, we can now work out the area of the sector, okay? Because what we can do is we can work out, if I use, let me use a highlighter. We can work out the area of the sector because effectively the area of the sector is this. It's going to be all of this, okay? We can work out the area of this sector here, okay? So all of this would be the sector. We can work that out. So if we were to work out that sector, okay, then what would that be? So we know that the area of a sector is a half r squared theta, which would be a half times 5 squared times a pi over 3, and that would equal a 25 pi over 6. So what do we know? So what does that mean? That means that this value here is 25 pi over 6, okay? And now that we've worked out that value, okay, we now need to work out what this value is here, okay? We need to work out what this value is here. Because once we got that value, we can take that away from the area of the semicircle. So to work out what this value is here, well, when we work out the area of the sector, we know that this and this, they are identical, okay? So what we can do is, if we was to work out the area of the triangle, we can then just take that away from the area of the sector, and that will give us this value here, and then we can just plus them together. So if we work out the area of the triangle is fairly simple because we know all our sides and angles, so we can use a half AB sine C. So if we use a half AB sine C, then that would just be a half times 5 times 5 times a sine pi over 3, okay? And if you used to work that out, you would get a 25 root 3 over 4. So we know that. And therefore, if we take that away, so if we take that away now from the whole area of the sector, which is 25 pi over 6, well, if we do that, that will be a 25 pi over 6 minus a 25 root 3 over 4. And then if we work that out, let's just put everything over 12. So if we do that, we get a 50 pi over 12 minus a 75 root 3 over 12. That just leaves me with a 50 pi minus 75 root 3 over 12. Okay, so what does that tell us? That tells us that this value here is 50 pi minus 75 root 3 over 12. I know it looks disgusting, but it will get much worse. Okay, so now I worked that out. Now what we can do is we know that the area of the sector plus that area there, that 50 pi minus 75 root 3 over 12, we can just plus them together. It'll give us the whole area of all of that area, okay? So if we do that, we get a 50 pi minus 75 root 3 over a 12, and now we're going to plus 25 pi over 6, okay? If you do that, I would say at this point, just put this into your calculator, or you can, actually, no, let's work it out. No, we don't even do that, because all it would end up being is we get a 50 pi over 12, or 50 pi minus 75 root 3 over the 12, okay, just over the 12, and then we just need to plus a 50 pi over 12, and that gives me 100 pi minus 75 root 3 over 12. And now at this stage, that tells us that all of this region, or not that one, tells us that all of this region, all of this, we know all of this is 100 pi minus 75 root 3 over 12. So we know that. We also know the area of the semicircle, which we worked out earlier, was 25 pi over 2. So all we need to do now is just work this out, okay? So if let me work out on the next page. If we work that out, we know the area of the semicircle, that was 25 pi over 6, and that's minus that 100 pi minus 75 root 3 over 12. Now, you may not put this to calculators, but I believe if you do, it will give it to you in a decimal form, which will be annoying. So let's just work all this out. So if we work all this out, then I'm going to split everything up. Okay, I think if I split everything up, it's easiest. Oh wait, no, let me just change this as well. This was a 25 over 2. The area of the semicircle was 25 over 2 pi. Okay, so now we've done that. If we split all this up, we get a 25 pi over 2 minus 100 pi over 12 minus 75 root 3 over 12. Okay, that's a plus. And now what we need to do now is we can just put everything over 12. Okay, so let's change this 25 pi over 2 into 150 pi. We're going to times everything by 6 on there to get it over 12. Okay, and that's 100 pi over 12 minus 75 root 3 plus 75 root 3 over 12. And therefore, this will simplify down to 50 pi over 12 plus a 75 root 3 over 12. And then this will simplify down again. So that 50 over 12, that simplifies down to a 25 pi over 6. And then that 75 over 12, that simplifies down to a 25 root 3 over 4. We just divide by 3. And then we've put it in the form we want. Because in the question, they want it in the form of a root 3 plus b pi, where a and b are just rational numbers. Well, we've shown that because if I just do it here, well, we'd have 25 over 4 root 3, okay, plus a 25 over 6 pi. And we've shown that 25 over 4 is rational, 25 over 6 is also rational. That would be our answer. Okay, for this one, we need to express 140 cosine theta minus 480 sine theta in the form of k cos 0 theta plus alpha. Okay, so nice one. All we need to do is, this is A. All we need to do is we have k cosine theta plus alpha. So that would be a k cosine theta. Also, this is given to you in your formula book, I believe. So you look there, and that would be k sine theta sine alpha. Okay. Now, if we know that in the question we have that 140 is cosine, we have 140 cosine theta. So that means that k cosine alpha must equal 140. And we have a 480 sine theta. Therefore, we know that k sine alpha must equal the 480. And in the question, what do they want us to work out? In the question, we just need to express it in that form, okay? And then we need to state the value of k, and then we need to give the value of alpha in degrees to 2 decimal places. Okay, well, what we can do now at this stage is let's work out what our alpha value is. Okay, so our alpha value, it's very easy. We can just divide, because we have the k sine alpha plus the k cos alpha. What we can do is we can do a k sine alpha, okay, over the k cos alpha, and that would also be just divided in turn by the 480 over 140. If you work that out, you'll be left with tan alpha is equal to 24 over 7. And therefore, our alpha value would be, to 2 decimal places, a 73.74 degrees. And to work out your k value, loads of ways you can work it out. I'm just going to use a little triangle here. So with this triangle, effectively we know that this is going to be a 24. We know this is a 7. By Pythagoras, this will be a 25. So what do we know? We know that, let's say cos alpha. Let's say work out cos alpha here. We know cos alpha would just be adjacent, which is 7 over 25. We can put that into the equation of k cosine alpha is equal to 140. So know that 7 over 25, k is equal to 140. And then if you work that out, our k value would be 500. You could also just put in your alpha value in there. I just didn't want to because I just didn't want to. Okay, so we worked out our k and our alpha value. So if we put that into the form of k cosine theta plus alpha, it would just be a 500 cos theta plus a 73.74. So for part B, we've been given this equation here of r is equal to a plus 140 cosine 30t plus 4ae sine 30t. And we're told that the maximum number of rabbits is 1,500. We need to find the complete equation for this model and then write down the minimum number of rabbits in the wood during the year according to the model. So look at this question. First thing first. This looks very familiar to the 140 cosine theta minus the 480 sine theta. So what we do is we rewrite whatever we had earlier, the r or the k cosine theta plus alpha. We're going to rewrite that now. What we're going to do is we're going to rewrite that in terms of the form which they have. Okay, so if we rewrite that, this is part B. Then before, if I rewrite what we just had, we had 500 cosine of theta plus the 73.74. Now with this new question, it's slightly different. It would just be a plus, or let me write it as r. So write it as r is equal to a plus 500, okay, cos, and that theta is now 30t, plus that 73.74. So that's now our new equation, okay? We are told that the maximum number is 1,500. Now, what you got to think about is, we have this cosine function here now. Now, what is the maximum cosine can be? Well, we know that cosine is always going to be between -1 and 1. So the maximum value we can get for all of that cosine is just 1, okay? Therefore, we know the maximum number of rabbits is 1,500, as they tell us in the question. Therefore, if we make r 1,500, that would equal a plus just the 500, because with cosine, the maximum cosine can be just 1, so that will just give us a 500 times the 1, so just a 500. Therefore, what do we know? Okay, we know that a, our constant value, is 1,000. So if we need to find the complete equation of the model, the complete equation of the model is just r is equal to 1,000 plus 500 cos of 30t plus 73.74, okay? And for the second bit, we need to find the minimum value. Well, the minimum value, again, when is cosine at its minimum? It's at its minimum at -1. Therefore, if it's at its minimum at -1, then we need to make cosine equal to -1. And therefore, what are we left with? We will be left with r is the number of rabbits, that would equal 1,000 minus the 500, because we make cosine equal to -1, 500 times -1, it gives us a -500, and therefore we know the minimum number of rabbits will just be 500. So for question C, we need to, we're told that the actual number of rabbits is at its minimum value in the middle of April. We need to use information to comment on the model for the number of rabbits, okay? So for this type of question, okay, what is T? Well, T is the months. It's the months which is after the start of the year. So what does that mean? Well, if it's the time after the start of the year, then if T was just one month, that's 1 month after the start of the year. So that's like at the end of January, like the beginning of February, okay? It's 1 month after the start of the year. If T was 2, that's 2 months after the start of the year. So that's like end of February. So then, again, with the March, it will be 3. But then April, well, April would just be in between that 3 and 4 then. Because end of April would be 4. End of March is 3. It's middle of April, just in between. So we know that for our question, we know that T would be 3.5. Okay, so that's the first thing. We know that T would equal 3.5. And if we know T is equal to 3.5, then, well, we can just use that and we can work out our values, which we need to work out. So to do that, we know what R is. R is 1,000 plus 500 cos 30, and then times that by 3.5 plus 73.74, which will give us 500.1, okay? Rounded down to 1 decimal place, which is accurate because, as you can see, that is very close to the minimum number of rabbits, which we worked out before was 500. So all we can say, so we need to comment. So all we can say is something like, since 500.1 is close to 500, the model is suitable. Okay, that's all we need to do. Write something like that. So we've commented. So now for part D, we have that the number of foxes during the same year is modeled by the equation of this equation here. The f is equal to 100 plus 70 sine 30t plus 70. The number of foxes at its minimum value after t months. We need to find, according to the models, the number of rabbits in the wood after t months. So really, all we need to do is we're told that the number of foxes at its minimum value. So we need to find the minimum value of this f. And then whatever t is at that minimum value, then we just put that value for t into our rabbits equation, and that'll give us the number of rabbits, okay? So if we do that here, this is d. If we do that here, then all we really need to do is, again, if I write out the equation here of f is equal to 100 plus 70 sine 30t plus 70, well, what would the minimum value be? Well, similar to cos, we know that it goes between -1 and 1, okay? So we know that for this question, it'll be at its minimum when sine of x is equal to -1. So if we know that, therefore, we need to look at our t value. That'll just be a sine of 30t plus 70, and then it'll just be all of that. When is that equal to -1? So if we work this out, well, obviously, if we do inverse sine of to -1, that would give us a 270. So we get sine t, not sine t, we get 30t plus 70 is equal to 270. And therefore, we get a 30t is equal to a 200. So then t is equal to 20 over 3. So we know that at 20 over 3 months, that's when the fox is at its minimum value. And then we need to use that same t value for our rabbits now. So if we do that over here, therefore we get r is equal to 1000 plus 500 cos of 30 times the 20 over 3 plus the 73.74. If you work that out on your calculator, you will get something like 1032.61. So therefore, if we round up, because you can't have 0.6 rabbits, something like that, we would just get 1033 rabbits. Okay, we need to pretty much use substitution for a sine squared theta to show that the integral can equal this other integral. Okay, so do this question. What is the first thing we should do? Well, first thing first, we know that from the question, a is equal to a sine squared theta. Let's differentiate this. So if we differentiate, we get dx over d theta. Okay, and that is equal to, well, what would that equal? Well, that would be a. You get a 2, which will come out, okay? And then still have the a, and that'll just equal a sine theta cosine theta. Because remember that if we're doing the chain rule, that sine theta would just differentiate to a cosine theta, so you get the cosine theta comes out, and then you also still have your sine theta as well. So we get this. And therefore, if we rearrange this, we get dx is equal to 2a sine theta cosine theta d theta. Also in the question, we can see that we need to get it in the form of sine squared 2 theta. So already that's telling me that, okay, we're going to need to turn this into a sine squared theta, which we can do now. And if we do that now, we would get, because we have the 2 sine theta cosine theta, so that would be a sine 2 theta d theta. Okay, so we know dx is equal to a sine 2 theta d theta. Okay, if you're unsure how I did that, that is from the double angle formula. So next bit, we now have that square root of a minus x. Now that square root of a minus x is a bit annoying, okay? It doesn't look that good. But how can we use that in our answer? Well, we know that x is equal to a sine squared theta. So if we have a minus x, then that's the same as the square root of a minus a sine squared theta, okay? And with that, what we can do is, what I'm going to do here is I am going to, let's actually take the factor of a out. So we get a, and in brackets we get a 1 minus a sine squared theta. And now obviously we know from another more trig rules, we know that that would be a times cosine squared theta, because we know that cosine squared theta plus sine squared theta equals 1. Therefore, 1 minus sine squared theta equals cosine squared theta. And now what we can do is we can just take out the square root now. So we'll get a square root of a cosine theta. Okay, so we know, so now we've transformed that a minus x is just equal to the square root of a cosine theta. Okay, now we just need to do our limits. So as you can see here, we have the limits of a and 0. So if we just change our limits, so let's do the a first. So we get a is equal to a sine squared theta. That would be a 1 sine squared theta, 1 sine theta. And if you was to work that out, you would get a theta as 90, or in this case, when radians, pi over 2. If you do the same thing for that 0 now, it will be a 0 is equal to an a sine squared theta. Divide by a, you're just left with a 0 is equal to sine squared theta. And that will just be a 0 is equal to sine theta, which then again just means theta stays as 0. So we've done everything now. We have done absolutely everything. If we do it now, we have the intervals of pi over 2, 0. And then if we look, we have x to the half. Well, what is x to the half? Okay, x to the half that's that a sine, let me just do it here, that would be a sine squared theta to the half. Okay, and that's times by the square root of a minus x, which we worked out is this a cosine theta. And then just dx, we know that dx is times by a sine of 2 theta d theta, okay? And if we simplify this down, we get a pi over 2, 0. This goes down to, we get a square root of a sine theta times square root of a cosine theta times a sine 2 theta d theta. And then again, that would go down to a, well, what do we have here? If we do everything together, we have a root a times root a times an a. So root a times root a is a times a. That'll give us the a squared. And then what else do we have? Well, we have this sine theta, cosine theta, sine of 2 theta. Now, that sine theta, cosine theta, that actually is, again, using the trig identities and stuff, that is the same as a half sine 2 theta. And then we also have our original sine 2 theta, okay? And therefore, if we rearrange this, as you can see, if we rearrange this now, if I just do it, well, we have the half a squared, okay, because this is times. So we have a half a squared. And then over pi over 2, 0, what are we left with? We are just left with a sine 2 theta times by a sine 2 theta, which is just a sine squared 2 theta. And then we'll have the d theta there as well. So the second bit now, we now use algebraic integration to show that that integral equals k pi a squared, where k is a constant to be found. Okay, so this is b. So to do this question, therefore, we have that the interval of pi over 2, 0 of, what do we know, of sine squared 2 theta d theta, okay? We need to integrate this. So how do we go about integrating something like this? Well, we have this sine squared 2 theta. So if we can try and write it in a way where we can get rid of that square, it will make it easier. So using trig identities, we know that cosine 2 theta, that is equal to a 1 minus a 2 sine squared theta, okay? Now, if we think about double angle rules and things like that, that means that cosine 4 theta must equal a 1 minus 2 sine squared 2 theta. And now, as you can see, we have some type of sine squared 2 theta now. Let's just rearrange this for that. So if we do that, we would get a 2 sine squared 2 theta, okay, and that would equal a 1 minus a cosine 4 theta. And if we divide by 2, okay, we divide by 2, we get a sine squared 2 theta that is equal to a half minus another half cosine 4 theta. And now integrating that is a lot easier. So if we integrate this now, we now have the integral of a pi over 2, 0 of a half minus a half cosine 4 theta d theta. Okay, and also don't forget in the question, I may have forgot it, but it's a half a squared, so don't forget we still have the half a squared here as well. And then what we can do is let's take out the factor of a half now. So take out the factor of a half, we're left with a quarter a squared interval of pi over 2, 0 of now it's just 1 minus cosine 4 theta d theta. So if we work this out now, we get 1 over 4 a squared, that'll be times by theta minus 1 over 4 sine 4 theta. And then now let's just put all this, and this is also being times by everything here. So, and this would be pi over 2, 0. If we put everything together, we get a 1 over 4 a squared theta, and that would be a minus 1 over 16 a squared sine 4 theta. And then if you put everything to pi over 2, if you work out your limits, you'll be left with a pi a squared over 8 minus a 0. Okay, that's the pi over 2, and then this will just give you a 0 here. Therefore, we are left with the answer of pi a squared minus 8, okay? So for this question, we have a balloon, it's being inflated. The balloon is modeled as a sphere. The rate of increase of the radius of the balloon is inversely proportional to the square root of the radius of the balloon. And at time t seconds, the radius of the balloon is r centimeters. We need to write down a differential equation to model this equation. So what can we do for this question? Well, if something is inversely proportional, then that must mean that if we think about it in this case, if we want to write a differential equation, in this case it will be dr over dt, and that would just be 1 over root r, because that would be, it's inversely proportional to the square root of the radius. That's where the 1 over square root r. If it's inversely proportional, that must mean that it has to be times by some type of scale factor. Let's call that scale factor k. So dr plus dt is equal to k over root r. Okay, so for part B, we're told that at the instant when t is equal to 10, the radius is 16 centimeters, and the radius is increasing at a rate of 0.9 centimeters per second. We need to solve the differential equation to show that the r to the power 3 over 2 is equal to 5.4 t plus 10. Okay, so what's the information we've been given? Okay, so this is A. So for this question, we've been given that they tell us that t is equal to 10. They tell us that the radius is equal to 16. They also tell us that dr over dt is equal to 0.9. Okay, so using that, we can actually work out what our k value is. Okay, so if we know dr over dt is equal to 0.9 now, that means that dr over dt is equal to k over root r. So 0.9 is equal to k over root r. We know r is 16, so that's the square root of 16. So 0.9 is equal to k over 4. K is equal to 3.6. Okay, so that k is equal to 3.6. So now we have that dr over dt, we know that is equal to a 3.6 over the square root of r. And what do we need to do in this question? We need to show that r to the power of 3 over 2 is equal to 5.4t plus 10. So we need to now integrate both sides. So if we were to integrate both sides, if I do it on the other page here, so I rewrite this out, we have dr over dt is equal to a 3.6 over root r. We need to integrate on both sides, so we need to bring all our r's to one side, all our t's or whatever to the other side. So if we do that, we will end up with a square root of r dr is equal to a 3.6 dt, and then we just need to integrate both of those sides. So if we do that, I'm going to rewrite this as r to the power of a half dr, and if we integrate this side first, if we integrate 3.6 with respect to t, it just becomes 3.6t, and then also don't forget as well, we're going to have a constant value, okay? And then let's integrate this side now. So if we integrate this side, what do we get? Well, if we plus 1 to the half, we get a 3 over 2. And then we divide by that 3 over 2. We end up with 2 over 3 r 3 over 2. And that would equal the 3.6t plus c. Remember, you only need one constant. And then once you've done that, well, they tell us the information earlier. They told us that when t was 10, r was 16. So we can just use that again to work out our constant now. So we do that, we get 2 over 3, 16 to the power of 3 over 2. And that is equal to 3.6 times 10 plus c. And this will help us work out our constant value. So we get 2 over 3, 16 to the power of 3 over 2. That is just the square root of 16, which is 4, and then cubed, which is 64. And that is equal to 36 plus c. So 2 over 3 times 64, what is that? That would be a, yeah, it doesn't go down to a nice number. That would be a 128 over 3 is equal to 36 plus c. And then just to get our c, it's very easy at this point. C would just be 128 over 3, and that would just be minus a 108 over 3, and then that would equal a 20 over 3. So we know our constant is 20 over 3. So now that we've worked out c, now if we put that back into the equation we had, so that would have been 2 over 3, r to the 3 over 2, and that is equal to 3.6t plus our c now, which is 20 over 3. Okay, so now we've got this. Now if we divide everything by 2 over 3, okay, we'd have r 3 over 2, and that would give us our 5.4t plus 10. Okay, question C is find the radius of the balloon when t is equal to 20. Give your answer to the nearest millimeter. So very nice question here. All we need to do is we have r to the power of 3 over 2 is equal to 5.4t plus 10. We literally just need to plug in our value of t is equal to 20. So we get 5.4 times 20 plus 10. We work this out. If you work that out, you get a 118. And then therefore r would be like the 1.5 like root of 118. If you work that in your calculator to the nearest millimeter, which in this case would be to 1 decimal place, that would be 24.1 centimeters. Okay, so for D, we need to suggest a limitation of the model. Well, we're inflating the balloon, but the model doesn't take into consideration bursting the balloon, right? We could burst the balloon, but the model doesn't take that into consideration. So for D, you can literally just say that a limitation of the model is that the balloon may burst, okay? The balloon may burst, and our model does not take this into consideration, okay? So for I, we show that k squared minus 4k plus 5 is positive for all values of k. Well, okay, how can we prove that it's positive for all values of k? Well, I'm just going to complete the square here. So if I complete the square on that, then if I do that down here, we have a k squared, it was a minus 4k plus 5. Okay, if we're to work this out, let's complete the square. We get a k minus 2 squared minus 4 plus 5, which gives me a k minus 2 plus 1, okay? Now, we've got this. Now, if we look at this, well, we know that a k minus 2 squared, okay, that will always be greater than or equal to 0 because it's a square number, right? Therefore, by that definition, then k minus 2 squared plus 1 will always be greater than or equal to 1. And that's for all values of k. It doesn't matter what value of k is, it will always be greater than or equal to 1. And since 1 is always positive and it's always going to be greater than 1, so you can write something like hence for all values of k, it will return positive values, okay? And now for D, okay? So for D, we have this thing here. We have a student was asked to prove this by contradiction, that there are no positive integers x and y such that 3x plus 2y times by 2x minus 5y is equal to 28. Now, this is the student's proof below. So as you can see, what he's done is he's made the 3x plus 2y equal to 14 and 2x minus 5y equal to 2, because obviously 14 and 2 are factors of 28. And he's proved that when you work them out via a system of simultaneous equations, both x and y are not integers, okay? And, well, they're not positive integers, they're not integers at all. So therefore, he said that, okay, this doesn't work. Now, what we need to do is we need to pretty much show the calculations and statements need to complete this proof. So how do we go about completing this proof? Well, all we need to do is we go through the factors of 28 effectively. So if we go through if I write them as factor pairs, if I write all of them, right, we have, use different color, we have 1, 28, we have 28, 1 as well. Okay, we have 4 and 7. We also have, therefore, we also have 7 and 4. And then we have the 2, 14, and then we have the 14, 2, which our student already did. So as you can see here, these are all the pairs of factors. And similar to what the student did with 14 and 2, we need to do the same for all these other factors. And pretty much when we work them out, prove that they won't be positive integers, okay? So effectively, we've already done 14, 2, the student did that. So now we move on. Let's start with 128 then. So if we start with, let's start with 128. So if we start with 128, that means that we would get a 3x plus 2y is equal to 1. And then we would get a 2x minus 5y is equal to a 28, okay? Now, if we work that out via a system of simultaneous equations, I would advise you that if you have a calculator like this, just do simultaneous equations on your calculator. Do not work this out. You don't have the time to be working this out. Put this all into your calculator. Okay. If you put this into your calculator, if you do this on your calculator, you will get x as 61 over 19, and you will get y as minus 82 over 19. Both these are not integers, hence that we know that 1 and 28 does not work. Okay, on to the next one. We do the 3x, 2y, and that will be 28, and then we do 2x minus 5y is equal to 1. Do the same thing on your calculator. If you do that, you'll get x is equal to 142 over 19 and 53 over 19. Again, this does not work. Okay, these are not integers, so we cancel this out. We move on. We do 4 and 7. So if you do 4 and 7, you get 3x plus 2y is equal to 4. And then you do 2x minus 5y is equal to 7. And if you do this one as well, you would get x as 34 over 19. And then we get minus 13 over 19. This does not work. they're not integers or positive integers, so you cancel that. And we just keep doing this effectively. We just keep doing this. So next one, we would do that 3x plus 2y is equal to 7, and we do 2x minus 5y equal to 4. This is very tedious, but this is what you have to do. It's tedious, but it's very easy marks. You just need to do all this. So therefore we get x is equal to 43 over 19, and then we get y is equal to 2 over 19 again. This is not positive integers, so we cancel this out. And the last one is that 2 and 14 we need to do. So we get a 3x plus 2y is equal to 2, and then we get a 2x minus 5y equal to 14. And if you work that out, you get an x is equal to 2, okay? So we finally got a positive integer. However, you get a y that would equal minus 2. Again, that's not positive. Both x and y need to be positive integers. Therefore, that, we also just disregard this, okay? And then, hence, we've tried to show that it does, but it doesn't, because we get no positive integers for both x and y. Hence that no factors of 28 can return positive integers for x and y. For x and y. Therefore, you can write something like, therefore, there are no positive integers x and y such that, and then we can just rewrite the equation 3x plus 2y, 2x minus 5y is equal to 28, something like that, okay? And that'll be it for this paper. I hope you enjoyed this, and I will see you on the next.